All right, if we were to solve these two, so number 29 says the function f is graphed in the xy plane. If x squared plus kx plus 8, where k is a constant, what is the value of k? All right, well, I can look at these and I see my intercepts are here at -4, -2. So I know that I can create a binomial that looks like x plus 4, x plus 2 equals 0. If I know those intercepts, I can create those binomials. So now if I were to FOIL, I would end up with x squared plus 2x plus 4x plus 8 equals 0. And so I end up with x squared plus 6x plus 8 equals 0. So therefore, k had to be equal to 6. So this is a question from the PSAT in 2019 using information that we know, using strategies that we know. Okay, if I know those are my intercepts, I can create two binomials, I can FOIL it, and then I am in the form of my standard form, x squared plus 6x plus 8 equals 0. Second one, what is one value of x that satisfies the given equation? Okay, x minus 7 squared minus 25 equals 0. Well, I could rewrite this and say, well, x minus 7 squared then will equal 25. And using what I know to solve with square roots, I can take square root of both sides. So I end up with x minus 7 equals plus or minus 5. So that tells me then that I'm going to split this into two. X minus 7 equals a positive 5. So if I add 7, x equals 12. And then I could also say x minus 7 equals a negative 5. Add 7, I'm going to have x equals 2. So I actually found two solutions to this one. Question asks, what is one value of x? So it's going to be probably a multiple choice question. So either 2 or 12 is going to be a solution. Also on these multiple choice questions, if they give me one like this, what is one value? I can put in whatever they give me for those multiple choice ones to make sure it works. Okay. So here's two that showed up on the PSAT using exactly what we've talked about recently. So we should be able to do these when these appear on a PSAT or somewhere else. All right, so let's start on concept 8, which is complex numbers. So complex numbers are going to open up a whole new world of what we can do using square roots. All right, complex numbers are based on a number whose square is -1. So this is something that we've never worked with before. Now I have something, when I square it, I actually end up with a negative value. And the only way this will work is if I'm dealing with what's called complex numbers. So like I said, we're opening up a whole new arena now to work with, where when we square something, we actually get a negative. The imaginary unit I, okay, it's called the imaginary unit, is the complex number whose square is -1. Meaning if I take I and square it, I end up with -1. Connor, what's I squared? Okay. All right, this is important. You will start to see this now a bunch, where we're going to have i's happening, and if we have some multiplication where we have I times I, we end up with I squared. But really, I squared equals -1. Do not think of I like a variable x. Okay, we're not solving for I. I is simply called that imaginary unit. So it's similar. Well, I won't even go that far. Okay, I is called the imaginary unit. Also, we can say I alone is the same thing as square root of -1. All right, which makes sense because we could solve if I squared equals -1, if we took the square root of each side, then simply I would equal the square root of -1. These two relationships you need to know. So again, box them in your notes, put big stars next to them, highlight them, whatever you need to do, you need to memorize and know that whenever you see an I squared, it is actually a number. I squared is -1. If you ever see square root of -1, now we can do square roots of negative numbers because square root of -1 is simply I. So our answers could have I in them or not, depending on which direction we're going. All right, these two are important. Okay, so for example, if I want to do the square root of -a, up until the day, whenever I saw a negative under a square root symbol, I would throw up a red flag and say, can't happen, can't do it. Well, now that we do have this imaginary unit I, we can work with this. So really, I can break this apart and say, well, this is -1 times a. All right, -a is the same thing as -1 times a. My properties with square roots allow me to break these into two individual square roots and multiply those together. Square root of -1, we just identified that relationship. Square root of -1 is I. So we no longer have that square root of a negative going on. Square root of -1 becomes I, and then this is left as square root of a. And we are done. So we will not have any final answers with negatives under a radical. Okay, because we can rewrite as a product using -1, square root of -1 becomes I. So the final answer on this one is I square root of a. Still, again, we want to make sure square roots are all the way to the right. We could do it with actual numbers. We could say -3. Okay, so you do this one. Tell me what you come up with when you take the square root of -3 using I. All right, this one should be pretty straightforward based on that one that we just did. So I could break this up and say -1 times square root of 3. So this becomes I root 3. So we no longer have that square root of a negative. Now we have I root 3. And if this was a better one, and say it was I root 4, we would simplify that to be I times 2, which we're going to get in the habit of writing as 2I. We'll get to those. Okay, what about simplifying square root of -18? All right, you do that one. So this one's pretty straightforward again. We can rewrite this as a -1 times square root of 18. Square root of -1 is I. Square root of 18 in simplest form. What is square root of 18 in simplest form? Eva. 3 root 2. Because remember, square root of 18, I could simply write that as square root of 9 times 2, which is square root of 9 times square root of 2. Square root of 9 is 3 root 2. So make sure you're in the habit of breaking these down as far as possible. Proper mathematical notation to write this now, we will write 3I root 2. All right, so we treat I where we would move it to the right of any coefficient. Okay, so it's not x times 3, we'd write 3x. So same thing with a coefficient with I, we write 3I, not I3. Blake, did you have a question? Nope, nope, there's no plus minus here. Only time plus minus comes into play if we are undoing a square root. So, or I'm sorry, undoing a squared. So there is no undoing of squareds going on. All right, true or false? square root of negative 64 is the same as a negative of square root of 64. Let's look at this piece on the right first. A negative of square root of 64. I do the square root first, so we'd have 8, and this negative would just drop down. So a negative of square root of 64 is simply negative 8. Negative square root of 64, we would think of that as square root of negative 1 times square root of 8. So again, that becomes not square root of 8, square root of 64. So it becomes I times 8. Therefore, 8I is not the same as a negative 8. Because remember, I is the same thing as negative square root of 1. So it's 8 times negative square root of 1. Still, not the same. So be very careful where your negatives are occurring. Are they under your square root symbol, or are they outside of your square root symbol? Because you will get different answers. Now let's talk about the relationship between imaginary and complex numbers. So we did all that practice there to identify what I is. I is that imaginary unit. Now let's just do negatives under our square roots. Now we can actually write a complex number, which will be in the form of A plus BI. So complex numbers have imaginary units in them. That's what makes them a complex number. Just like we've been doing all along, A and B, those variables actually represent numbers. Those are coefficients. So if we have something where we have A plus BI, that is called a complex number. It has that imaginary unit in it. And we can become even more specific. This would be a real number. That A, it could be like 5, 7, negative 15. That is a real number. That A represents a real number. This is our imaginary part. Obviously, it has the I in it, so that is the imaginary part. Okay, if B is equal to 0, then the B times I goes to 0. So the number A plus BI is considered just a real number, because really it's just A. All right, so if B is 0, my complex number A plus BI, we could say is a real number because the BI goes to 0. I don't even have to worry about that. So all I'm left with is A. If A equals 0 and B does not equal 0, the number A plus BI is called a pure imaginary number. Okay, because really this just becomes A plus BI, which is simply BI. There's no real part to it at all. It is just an imaginary part. So this is called a pure imaginary number. It's just some coefficients times I. There's no real part to it at all. Okay, let's look at now adding complex numbers. So one thing I want to note here, because this happens on every single test when I get to a test, and I ask you to add two complex numbers together, and you see these two parentheses going on, you see two binomials, and say 2 out of 10 students will treat this as multiplication. This is not multiplication, okay? Do not trick your brain into thinking that you have two sets of parentheses that you have to multiply every single time. Okay, I put in there plus, we're adding these together. The parentheses are simply separating our two complex numbers from each other. So 4 minus 3i is one complex number. 4 is the real part, 3i is the imaginary part. So this first set of parentheses is one complex number. So I'm doing one complex number plus another complex number. All right, so make a note to yourself that parentheses, if I see two sets of parentheses, I'm not going to multiply these together. Pay attention to what operation is taking place between your parentheses. If there's no addition or subtraction, yes, then you would multiply. But on this one, there's an operation between it, which is adding. So we are simply going to add our complex numbers. So we can treat these as like terms. So we can only add real parts, and we can only add imaginary parts. Okay? Only add real parts, and only add imaginary parts. So on this one, my real parts, I'm going to have 4 plus a negative 4. And then I'm going to add negative 3i plus 3i. 4 plus a negative 4 ends up being 0. Negative 3i plus 3i ends up being 0 as well. And so final answer on this one, all I end up with is 0. But be very specific. We can only add the real parts together and only add the imaginary parts together. Subtracting complex numbers. Again, there's this operation between my two sets of parentheses. The parentheses are only clearly identifying the complex number pieces. Okay, so 5 minus 3i is one number. It's one complex number. So I'm taking one complex number, subtracting another complex number. So again, I'm going to, in this case, subtract the real parts and then subtract the imaginary parts. So my real parts are 5 minus a negative 2. Be very careful with your signs. And then my imaginary parts are going to be a negative 3i minus 4i. Okay, be very careful with those signs. It's negative 3i minus 4i. So 5 minus a negative 2 would be 5 plus 2, and so that ends up being 7. Negative 3i minus 4i is a negative 7i. So my final answer on this one, I would have 7 minus 7i. That would be my final complex number after subtracting these two complex numbers. Still have a real part, and I still have an imaginary part of my complex number. Now let's look at multiplying complex numbers. So again, I have two sets of parentheses, but there's no operation in between those. So here, these are being multiplied. The first one is just 3i. There is no real part to it. It's a pure imaginary number. It's just 3i. I can multiply imaginary parts with real parts. So this one I'm going to treat just like I normally would, where I'm going to distribute into each term. 3i times negative 5i would be a negative 15i. 3i times 2i would be a positive 6i squared. What is I squared, though, again? Negative 1. You must not forget that. All right, you need to know that relationship. I squared is negative 1. So this is really negative 15i plus 6 times negative 1. So this is negative 15i minus 6. Final answer now we want to write as negative 6 minus 15i as our final answer. All right, again, we start out with the real, and then we end with the imaginary. That is standard form for complex numbers. Real, then imaginary. Real, then imaginary. I want to see it as negative 6 minus 15i, not negative 15i minus 6. Again, you have to know that I squared is negative 1. When you have to, because whenever you are multiplying and you have two i's going on, you're always going to end up with that I squared, and you have to make that connection in your mind. Oh, I have an I squared. That's actually negative 1. I can keep going. If you left it as I squared, you would not have completed the problem all the way to finish. Do another one. So now I have two complex numbers where they each have a real and they each have an imaginary part. All right, let's take a second and you do this one. You're going to have to use FOIL, but you can combine real and imaginary parts and then come up with a final answer, which will simply be one complex number with a real part and an imaginary. Okay, so if we want to multiply these out, we would use FOIL. And so we'd look at our first term. So 4 times negative 1 would be a negative 4 minus 8i for our outside terms. Our inside would be a minus 3i. And our last would be a negative 6i squared. Okay. We can combine our like terms of our negative 8i and our negative 3i. And so we have negative 4 minus 11i minus 6 times what? Negative 1. And so we can keep going. So this is really negative 4 minus 11i plus 6. We can combine my negative 4 and positive 6 to be a positive 2 minus 11i. So final answer, 2 minus 11i when you are multiplying these two complex numbers together. Last one, you do. So negative 6 plus I, negative 6 minus I. Tell me what you come up with for a final answer. Okay, on this one we can FOIL. First term's 36. Outside term positive 6i, inside term negative 6i, minus I squared. Those middle two terms are opposites, so those just equal 0, so we don't have to worry about those. So all we're left with is 36 minus I squared. But again, I squared is negative 1. So it's 36 minus a negative 1. So we end up with 37. So we can have two complex numbers. When we multiply them, our answer simply becomes one real number. So we can work with complex numbers, and they do turn into real numbers based on how they're set up. We're going to talk a little bit more about that tomorrow. Okay, so for today, page 253, 18 through 26. Also in IXL Algebra 2, I1 all the way to a 75. Okay, have those done and ready to go for tomorrow.